requirements. Since there are only 15 pieces of data, what we need to check. You know what it's asking for there?
What?
For DI or D1, I guess.
Oh yeah. Oh, okay. I guess it wasn't looking for an answer. Okay, right there. I was thinking it wanted to answer right under D. I guess it's DI, right?
Yeah.
Check your requirements. Since there are only 15 pieces of data, what will you need to check? Hmm.
Hey.
Well,
There. What's going on?
How are you guys?
What do you think of that? I don't know what to
Okay.
think.
Can you guys hear me okay?
Yeah.
yeah.
Cool. I'm just going to try to do it on my computer, not my iPad today.
Hey.
Okay, so have we started part 2 yet, or?
Yeah. We've gone into a little bit. Well,
Okay.
you know how far we went into it. We're like halfway through 2.
Okay. Okay, can I ask a question really quick on part 1?
Sure.
I just don't really, for most of it, I think I understand it, but, for this number 3, based on, I guess, is there anything like, I don't know, I guess I don't really understand the wording. That's why I thought I'd just ask you guys.
So what's your question about C?
No, for 3.
Oh,
Sorry.
number 3?
For the part 1.
Oh, part 1.
Yeah, sorry.
So what about it?
I just didn't understand like what the chart was for.
Oh, it
So
just
they're
tells
saying that
you, like,
what?
do you remember like the level of significance? The level of significance tells you when you can like reject the null
Uh,
hypothesis. You know, it's below like 0.25, for example. That's kind of a common one to choose for it. And so there's since you choose 0.05 as alpha, there's still a little chance that it could actually be right if you reject it.
uh-huh. Okay. I think I was hearing you okay, but okay.
So like a type 1 error is when I believe is when you reject the null hypothesis, but it's actually correct. Reality it is
Okay.
correct. And then the type 2 error is just the opposite. You accept the null hypothesis, but it's actually false.
Yes.
Okay. So the type 1 is, let me see if I got them straight in my head. So the type 1 is when you reject it, but it's true.
Yeah, I think so.
Type 2 is when it's false, but you fail to reject it.
So
I'm trying to think of a funny way to like remember that for the future. Type 1 is true. Okay. I don't know. I'll have to think of some funny way to remember that. But okay, thank you. I just wasn't sure.
yeah,
Okay,
I'm
so we're on 2.
We're on number. Do you have any questions about 1 or 2? Any parts in that?
I haven't
Yeah.
done it, but I think just going over like the points, there's nothing that I'm like, oh, how would we do that?
Okay.
I guess what did you guys say for C on number 1? If analysis,
I don't know.
what is it called?
So you said C on number 1?
Yeah, on
Okay.
part 2, I mean. You know.
Oh, on part 2.
Yeah, sorry.
Okay, yeah. Historical data. You use descriptive statistics. And I just put the numbers in, and I made a histogram, and I think there's another function to calculate the descriptive statistics. So I don't know. I just pasted that chart into there. I didn't want to really type out a paragraph.
I think maybe my bigger issue is that I read up to like 4.4, and then I skimmed the next section past, like, you know how there's a step. Anyway, there was another example, and I'm realizing I skipped the type 1 and 2 paragraph, and that's why all of a sudden I was like, wait, what are you talking about? Errors? But I skipped the one example, and I skipped that a little bit. So I'll go back and study it. Don't worry about catching me up. I'll get on top of that. Thanks. Okay. Going back to... Okay, so are we on to... So just where are you guys at, and I'll just jump in with you.
We're at D, number 1. I guess, yeah,
Oh,
1.
okay. I thought you were on... Okay.
So,
Want to increase power.
check the requirements. Since there are only 15 pieces of data, what will you need to check? And I don't really know.
Wait, what are you on?
They want to know what you will need to check.
2D. Okay, I thought you were on 1D. Okay. Check the price. Check. What? Hold on. Brand, do you have any ideas?
Oh, sorry. I was looking at that. What's up? What part are we on?
1D.
1D. Um, oh, okay. Oh, you did this one, right?
I'm just gonna pull up the key for a second and check that. I pull it off.
Hey, Claire, you did have a question on 1D, you said?
No, I mean, no, sorry, we're on 2D. So Colby and I weren't sure, so I was just wondering if you...
Oh, okay. Sorry. I was like, what the heck? No, I don't know about this one either. I don't understand what they're doing.
What will you need to check? I have no idea what they want from that. No.
Okay, so I don't remember going over this a little bit, but on the answer key it says, what would you need to check? It says make a QQ plot of the data to check for normality.
Oh, okay. That. Yeah. Okay, yeah. It's to check and see if it's normal. But
I guess is that the only way, other way that we would know that it's normal? Like, don't we know? I'm trying to think overall. We've learned that you can know the population is normal by where did my it's over here. You can know the population is normal because of the sample's normal because of the population and stuff. But for this one, we just have to do the QQ because it doesn't give us a population.
Well, it does. It gives us an average and everything, which kind of, because they only referred to it once, the QQ plot, and then they never really talk about it ever again until now. Actually, I don't think they even mentioned it in the lesson, QQ plot.
Yeah, because I don't. So what I'm wondering though is because typically it will state in a problem if the population is normal or not normal. You know what I mean? And then this one, it doesn't. It just says assuming that the national standard deviation is 5, but it doesn't. Maybe I misread it, but it doesn't say anywhere in this question that the population is normal, right?
It doesn't.
No.
Like
So
in
that's
other,
why I'm wondering if when you don't
like
know that,
what's that?
I'm saying you don't know that, then do you have to do the QQ plot?
Yeah, I mean it makes sense, but
Oh,
like in the other problems, like the when we were talking about the central limit theorem, they had other samples that are about this size, and we could say it was approximately normal because of that theorem. I think you have to at least have
Oh.
more than 5 samples, right?
Yeah.
Well, so this is something.
it
Okay,
makes sense
Colby,
to
will
me.
you repeat that one more time? Because I just found the volume key for Google Hangouts. Now I can hear you all speaking. What was the
So,
last part of what you said?
like in the last few lessons, all we had to say pretty much, to prove that it was normal is that you had enough like samples to say that it was approximately normal. If the original curve wasn't normal. You know what I'm saying?
Yeah.
Now suddenly it's changed. Now we have to look at the QQ plot to figure out if it's normal.
Yeah, so that's what I was wondering. It's like, is it because because they don't state the population, then we should assume we use a QQ plot? You know what I mean? Like, I wouldn't, like, how would we know when to use that? You know?
Yeah.
I don't remember it saying when we learned about QQ plots.
Yeah, it mentions it only briefly. It doesn't even show you how to make one. It's kind of
Details. Yeah, little details.
But yeah.
I was trying to pull back up, but anyway, I don't know. I wonder if that's a question we could ask, or maybe just email her or something. I guess.
I wonder if it's not a like a sample distribution, like a mean sample distribution. I wonder.
What do you mean, the D or like?
Well, like when we use like the central limit theorem, we're assuming that our normal, like our density curve was like a sample mean, and here it doesn't talk about it at all. So I'm wondering if that's what makes it different.
That. So wait. So you're saying I understand what you're saying that we use the central limit theorem more when we were talking about normal populations. But what were you saying was missing here?
Oh, because it never mentions. I forget the exact name. It's like a sample mean distribution.
Oh yeah.
It doesn't
of,
mention
of
cost. So
yeah, it doesn't mention it of the sample mean or of the population, right?
yeah, it
That's
wants to know if the average is close to the national average. So maybe that's the difference.
yeah. So I guess I think that's what I kind of along the same thoughts of what I was thinking is that because it doesn't state anything, then we'd have to do the QQ plot to check
Yeah.
to see this because it doesn't have of the population or of the thing. And so maybe that's the whole gist of making this inference thing is that you don't know enough of the population to even compare the sample size. So maybe by comparing the sample, you know what I mean, comparing what you do have through a QQ plot and stuff, then you can make the, well, I mean, that's not the inference, but just starting out there and then you can solve for those nulls and make the inference of,
Hmm.
I don't know, that was a really wordy statement, but I guess that's just part of it. So you can take almost anything and start analyzing it. Okay, so
I think I kind of get why maybe, because for it to be like a sample mean distribution, you'd have to sample from like the entire like nation, right? He's only sampling from his clients, right?
yeah,
So I mean, you can't really call it that
you can't
because
call it the
he's
sample.
only sampling from his clients, so it wouldn't really be true.
Yeah. Okay, I'm going to read this one. According to the report, the average person is buying a second home. What's that?
Which one are we on?
I was just reading to one more time, the paragraph, the problem, one more time to make sure I understood it.
Oh, okay.
Sorry. But we can move on pretty shortly here. Let me just read this a little bit. Age of a person buying a second home. Okay, so next question is state the null and the alternative hypothesis.
Mm-hmm.
So it's just so the null is that the average is 47, right? The national average.
Yeah, I think so.
And then the alternative, he's not looking to see if they're older or younger, right? He's just seeing if it's different.
Yeah, I think he was looking to see if they were like the same or close.
Yeah. So it would just be that it's not equal to 47, right? Because it's not above or below. It's not equal.
Right. Yes, I agree.
Yay. Cool. Okay, so compute the test statistic. What is the formula to be used? After writing down the general formula and put the numbers you'll use to show this work, finally use Excel or a calculator to compute your test statistic. Isn't the statistic just like a probability, or I guess it's the z-score that solves for the probability?
Yeah.
And so do we just find the mean of the ones that we do have and we minus those from
Yeah. So
equals?
6, 8, 7, 3. divided by.
So I got the average of 46.7. Is that what you guys got?
Yeah.
Yes.
Divided by division of 5. So, oh wait, I just solved for something. Darn it. Where's my favorite thing? What was the z-score you guys came up with?
Negative 0.03409.
For a Z-score?
Yeah.
Yeah. I got, what did you get, Brand? I got negative 0.206.
I'm still eating. X.
Did you divide by the number of samples?
Yeah, and that was 15, right? I keep opening it
Remember
wrong.
the square root?
I didn't divide by the number of samples.
Why not?
Just because it wasn't like a sample distribution. That's what I was guessing anyway. Now let's try out another.
Does it say, let me go back to the lesson here. Because when I was just looking at, well, I don't know. Okay, so test statistic. Assuming the null is true, we assume the true mean. Make this. Okay, so under the test statistic, it says, however, and I just guessed to do the sample size. I just looked out. But it says here is saying, however, it is important to remember that the standard deviation of the x mean is standard deviation divided by the square root of the sample size.
Uh-huh.
So they just have us put that in there to do the sample size in it. But I don't know. Let me just go over my math again too, because I don't think it's.
Well, that's the thing. They never refer to them as samples. They just call them 15 pieces of data.
Yeah, and like going over that same thing with the when to use a z-plot and when not. I thought, you know what I mean? We're thinking, oh, we don't really count it as a sample mean. I think a lot of this is also just learning like different vocabulary. You know what I mean? Just getting used to how they do it.
Yeah.
Still, okay. So equals the square root of 15, right? And then 5 divided by. Isn't the standard deviation 5?
Well, that was the national standard deviation.
So it's 5 divided by the square root of 15.
Well, that was for 47 anyway. But
Well, 5 is for 47, right?
Yeah, for national average. The the standard deviation I got was, I mean, for the data that it gave anyway,
Uh-huh.
was like 8.8.
Okay, let me look at the answer key again. So, okay, so under the sample key, it has 0.20910 positive.
For
And
the
I
Z
got
score.
for the z-score. Yeah. And it also just has the mean the mean of the sample minus the mean of the population divided by the standard deviation over the square root of the sample size.
Okay.
But even when I just did that, I mean, my math could be just off, but when I just did that, I've done it twice and I still get 0.20658. So I don't know what's wrong.
You said the Z score was positive.
And the answer it is, but I got negative continuously. It's
Yeah.
got to be negative.
The I, I mean, like the mean that I got was like 46.7.
I think that's what I got too. Yeah, 46.73. Mm-hmm.
Yes.
Yes.
Yeah, I agree. Sorry, keep going.
That's okay. It makes sense. Why would it be positive for them?
Guys, I have a question.
Yeah.
What, okay, so we got the formula, uh, bar of x minus the mean divided by standard deviation divided by square root of the sample. What is the bar of x? What is it in this equation? What do we use it for again? What do we plug into the bar of x?
So the bar of x is the sample mean. So it's when you just take like the data of a sample, an observation, and you find the mean from it. So looking at this problem, when you go up and you look at his 15 data,
Uh-huh.
it's using those, and you put the mean, you solve for the mean of all of those, and then that's what you pop into the equation.
Okay. And then we're subtracting the mean, which is what? The national?
Yeah. Mm-hmm.
What is our national mean? Do we have to put it into the graph to find out?
No, going up to the problem, it says according to the report, the average age of a person buying a second home as an investment rental property was 47 years old. So that's the average.
Oh, okay, okay.
Yeah.
Oh, wait a minute. All right, let me recompute.
That's fine. I don't understand how they would. I mean, Kobe? Did you just stick this data into Excel? Because that's what I did.
That's what I did too. Did
Yeah,
you,
and
for the standard deviation, did you use 5?
the what?
For the standard deviation, did you just use 5?
Yeah, I just used 5.
Okay. Is-
And on
okay.
the answer sheet, it doesn't say anything. It just gives the statistic, and then it gives the definition. It just gives the answer what the z-score was.
Yeah.
Hey, Colby,
Yeah.
what did you get for your answer for your z-score?
Well, I did it. For some reason, I guess I did it some different way. But so it was definitely wrong.
Yeah, I think I got what you got. That's what I was wondering.
Well, it shows on the answer key that you're supposed to divide by the square root of the sample size.
Yeah.
Five.
I still have to think about that some more.
Come on, calculator, clear. Fine.
I wonder. Let's see.
Yeah, I don't know. I'm not getting the right answer.
What? Let's see. The z-score is 0.02 something. Right?
Yeah. It's
To
0.029. Or it's no. Let me restate it. 0.209.
Yes.
Okay. 0.2091.
That's weird.
Yep.
Use a positive because I think that's the answer they. Well, it wouldn't matter anyway. Yeah.
How are they getting?
What?
How are they getting that as their z-score?
I don't know. I'm gonna see if I can work the problem backwards.
Well, I mean, it doesn't really matter if it was positive or negative in this case because you're taking both tails. So,
Oh, really?
yeah.
Oh, because it doesn't matter. Okay.
Yeah, you're looking at both extremes.
So when it's just not equal to, it's both tails. If it's good or less,
Yeah.
then it's one tail. But even then, I think for me at least, it looks like they're using a different mean. Because if you work the problem back, their mean is, let me just make sure.
Like
Their
48.
mean, yeah, 47.809.
I don't know. I mean, I don't know where they get 48 from.
It's 47.8, but yeah, I don't either. I don't know.
I think it's just a mistake. I think it's just supposed to be like
Yeah.
a negative there.
Yeah, and we're pretty close. I mean, I got 0.2066, so it's just barely off.
Yeah.
No worries. That's weird. We'd have to ask. Okay, cool. So we just put that in the area under the applet, right?
What's that? Oh yeah, and yeah,
Put that-
yeah.
And then it's both the tails.
Mm-hmm.
And then I got I'm just gonna put in their answer. I got like 0.83.
What's that?
0.2. Yeah, I got 0.834.
Yeah. That's,
Yes.
Woohoo!
Goody.
Compare the p-values of level significance at the alpha level. The alpha is 0.01.
I think it says 0.05.
Oh,
Yes.
yeah. It's just what's stated in the question, huh?
Yeah.
Okay.
So the p level is greater than the level of significance, so we don't reject it.
Hey, I have a question.
Yes.
If by chance you plug it in and it is less than 0.05, does that mean we fail it?
Yeah.
So that's how we know if the equation is not true, we fail it.
Yeah, if your p-value is less than 0.05, then you reject it, the null hypothesis.
So that
Okay,
means
that makes
that it's because the probability is extremely unlikely
Yeah.
for it to happen. Therefore, we reject the null because it is happening, right? And so that's cool. Okay. Oh man.
State your conclusions in terms of the alternative hypothesis.
So we accepted the null hypothesis.
I don't think so.
Wait. Did I just get this backwards?
They say, so we fail to reject the null.
So we
They-
accept the
they-
null.
Well, we already accepted, but they fail to accept.
So technical. Just kidding.
Fail to reject.
Okay.
And
We failed to reject it. So. We
I
failed
guess
to
because you
reject the
already
null.
true, you already. That's the assumption that it's true. So
So we're just not, again, we're not proving it wrong. We failed to reject. Seven. So what does it mean in terms of the alternative hypothesis?
it was.
That it's either more, it's just not 47. I guess I'm just wondering, like, how do we do it in terms of the alternative hypothesis? Because I definitely just did it in terms of the null hypothesis. We don't
the
reject the null hypothesis.
the alternative hypothesis was it cannot equal 47.
Yeah.
So I guess it is 47.
Is equal 47. Woohoo! Okay. So what do we do? What action do we suggest the realtor take? Keep aiming for those 47-year-olds? As clients?
I mean, these. I don't know. What action, if any? you
What action
suggest?
is
Let's take these things. Let's go to conclusion.
I would say just keep on keeping on with those 47-year-old people buying homes.
Focus on people who are 47. I don't know.
Yeah, that's what I would say. Hey, going back to that answer key, I just wanted to read this because I think for the one that we just answered, their wording for the doing it in terms of the alternative hypothesis is as we have insufficient evidence to conclude that the mean age of people buying a second home is different in this area than that of the national average. So I just thought that was a great word, interesting wording.
Yeah. The technical way.
So, well, I definitely don't feel quite as sure with this section as I have in others, but I just, I don't know, I guess just more practice and stuff.
Yeah.
Are we ready for the quiz on that note?
So.
Yep.
Okay. Start. A hypothesis test. Okay, so I'm on number 3. Is everyone there?
Yep.
Okay, a hypothesis test consists of two hypotheses, the null and the alternative. Which one represents the status quo?
No.
Woohoo! Which hypothesis involves equality? The
No.
alternative? The null?
It does, doesn't it? Because not equal is always associated with alternative.
Yeah.
But it looks like they're just telling you the equal sign up in the court. I mean, up by 4. So I don't know. I mean,
Oh.
Western kind of like that too.
So you're saying, okay, so I guess what we're saying is just the equal sign. I'm sorry. I just saw, like, I'm like, oh, the alternative is the one that has the greater, the less, the not equal to. So the null is always equal to, right?
Yeah. That's the only choice you have.
My bad. So glad we can take this together. I would have cruised through that. Like, got it. Woohoo. Okay, so the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5.
Fitness correlation obviously seems to be true.
The
I think
null?
it's isn't it?
I
Yeah.
think it's the null.
Say the null is true.
It's the answer to every question.
I
It's the
know,
null.
for real. Getting me nervous. Okay, suppose the null is the mean of 10. Use this information to answer 6 through 8. Which of the following would represent the alternative hypothesis for a two-tailed test?
Not equal.
Yeah, not equal.
Not equal. Yeah. Which of the following represents the alternative for a left-tailed test? So, less than?
Yeah, I think it's less than 10, right?
Yeah, so mean is
Not
less
sure.
than 10.
Less than.
That makes sense to everyone.
And then
So
it's just,
right tail.
yeah,
will be
right
greater.
tails for greater than 10.
True, this isn't as bad as it. Well, it's actually not 10 questions, darn it. Man, these are getting longer and longer. Boy.
Oh, 21 questions.
Oh my word. Okay, the outcome hypothesis test is determined by comparing the p-value to the level of significance or alpha. Use this information for 9 and 10. Which relationship will result in failing to reject the null hypothesis?
It's greater.
I think it's. Yeah. So which relationship results in
P-value.
Oh, it's a mean.
Yeah, it's greater, isn't it?
Yeah, P
So when the
greater than A.
p-value is bigger than alpha, so it happens more often than alpha.
Yeah, I think so.
Which relationship will result in rejecting the null hypothesis when the probability is less than alpha, right? Like that's like the boat example they gave, right? When the boat capsized,
Oh, yeah.
and they found that the average there was like extremely impossible according to what they had. Okay, cool. Thanks. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was 1,500. They're concerned that the true mean is actually higher than this. Use this information for 11 to 12. So their concern is that people are claiming more than 1,500, which was their average. So which is the alternative for the hypothesis? The claim is greater
The
than
average is greater than.
Greater than?
Yes.
Yeah, that's what I was going with. Nice job. Okay, which of the following would be the appropriate null? The claim is equal to?
Yeah, equal.
Yes.
The insurance company randomly selects 40 claims and calculates the mean to be at 1650. The insurance, so I'll use this for 13 through 15. The insurance company assumes the distribution means it's normal. Is this a good assumption? I don't know.
See,
Oh, 14. 14 is which theorem or law justifies your answer to these questions.
What did you do for 13 though?
I
Oh,
would,
let's
I
take
mean,
yes.
I would say yes, but I mean, what they're thinking, you know, approximately normal. But I mean, this is a technical thing, maybe.
the distribution of the sample is normal. Oh, okay.
I think it's yes.
Okay, yeah, I would say yes too.
I think
Go ahead. What, Brent?
Oh, I said I think it's yes also.
Okay, I agree then. What theorem or law justifies your answer?
think it's
Law of
Okay.
large numbers?
right.
Is that what you guys think?
Which one?
So one is I thought the law of large numbers meant that the sample mean would be close to the population mean,
Yeah.
and that the central limit theorem would be the bigger they are, like the bigger the sample size, the more normal they are.
Mhm. Yeah. Pretty much.
So wouldn't it be the central limit theorem because we have over 40, so that's why we're assuming that it's normal?
Yeah.
Wait, why is it? I thought that was law of large numbers, though, isn't it?
I always get confused,
The,
but I'm
the
pretty
law of
sure.
large numbers has to do with the with the sample mean getting closer to the population mean as you take more samples.
So essentially, the law of large numbers would be, just to make sure I understand this right. If up here it said the mu or the mean of the population is 1700 and the mean of X is 1650, then I think then it would be the law of large numbers because they're getting closer. But
Mhm.
we're assuming that this is the normal distribution because in this 40, which is large, it's not so much because of the mean. Make sense?
Yeah, I think so.
Brand, does that make any more sense? The law of large numbers, or the tongue twister of all tongue twisters, is that the means get closer as the numbers get bigger. The central limit theorem is saying that it talks about distribution according to the sample size. Wow, it's like
Yeah,
the
that
first
makes
time I've ever defined them differently.
Well done.
Yay. Okay, so 15. Which of the following is a test statistic as defined in this lesson? Z.
Yeah, Z.
Okay. The historical mean of sales receipts at grocery stores is 150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypothesis. It's either equal to or less than 150. Well, the null is equal to and the other one's less than. She'll use the level of significance of 0.05. She takes a simple random sample of 36 cells and computes the mean to be 144. Uses information for the following 3. What is the z-score associated with this test? Okay, so square root of 36 is 6, and the standard deviation is 40. That's going to be over 150 or 154. So I got a z-score of negative 0.8999999.
Huh.
What did you guys get?
I got like negative 0.9.
Oh, boy.
Oh, that's essentially what I got. I got 8.899, so it just rounds up to
Oh,
0.9. Sorry, I was really excited to tell you all those names.
Hey, sorry.
Point.
I got a question.
What?
How do you set up standard deviation again? It's what is it minus the mean divided by standard deviation?
Yeah, so it's the mean, the x bar minus the population mean,
Oh,
divided by standard deviation over the square root of the sample size.
oh, okay. I forgot to do the square root. All right, I'm good.
It's okay, it's hard. Okay, so we just type that into. So we do, for this one, we do anything below the -1.
Huh?
For the probability.
I think you do, because they're looking for less than 150.
So
I
it's
did-
just the. Oh, go ahead.
I did the left tail.
Just the left
So we-
tail, right?
Left.
So I got 0.1841.
Yeah, that's what I got.
Brandon, did you get the right Z-score?
I did something wrong.
It's
Sure,
okay.
but the 144 minus 150 divided by 40 divided by square root of
Square
30.
root of 36.
Yeah, I did that, and I got a different number than you guys.
Which
Okay,
part
so
shade?
Did I put it in wrong?
Did you shade the left part, like the left of the Z-score?
no, I think he got the wrong Z-score, so he hasn't shaded that.
Oh, okay.
Yeah, I think
Yeah,
it's
so
4.
well, why don't we just break down your equation a little bit, and we'll see where the math is wrong. So the square root of, like, sometimes I just do the bottom of the denominator first.
Yeah,
So the square root of 36 is just 6.
yes.
So then you have 40, wait, what do you have? Yeah, you have 40, because that's the standard deviation of the other one divided by 6.
Yeah, okay.
So what did you come up with that?
I came out with 6.666.
Yeah, that's what I got too. So then you just do 144 minus 150.
Negative 6.
And then you divide it by the 6.66666.
Okay, I got negative 0.9. Is that what you got?
Yeah.
Mhm.
Did you see anywhere when we walked that through? Did you see anywhere that you're like, oh, I had accidentally done that wrong, or did you just plug it all into the calculator?
I had the right numbers. I don't think I put it in the right order though on my calculator.
Oh, okay. Yeah. Sometimes I just I'm just scared my calculator won't do it right, which is dumb because it's smarter than I am. But I just break it down.
Did you guys put a negative for your z-score or no?
It is negative, and that's very important. So yeah, you keep the negative.
And did you put 0.9000 for the 3 decimal?
0.900.
Oh, okay.
So negative 0.900.
And then for the p-value, you got 0.184.
Yeah.
Not negative, right?
No, the probability will never be negative because if you look at the graph, you can never get like a probability. It's just the area under the curve, so you're never going to get negative
Oh,
area.
right. You can never have. Okay. No, that makes sense. Okay, we're good.
Yeah. Good. That's fine. Sometimes just going over it. What inference should you make about the null hypothesis for this problem? So, okay. I know this should be the easy part, but I keep getting it mixed up. So right now, it's probable that we would get this mean, right?
Like the population?
Yeah, like according to the standard one that we already have, like the 150, the 140 is probable, like it's likely to happen. It's not odd. So because the p-value is bigger, we fail to reject the null, right?
Yes.
Yeah. Well, yeah.
Okay. Thank you for letting me just talk that out. Okay, there are two types of errors that can be made with performing a hypothesis test. Which one involves rejecting the null when the null is true?
Type 1, isn't it?
I think so. Colby?
Yeah, I think so.
Yes. It is.
A researcher decides, I'm really trying to think of something to remember the type 1 and type 2. And I keep thinking of like investigators when they reject the truth before they know it is. Anyway, I'm just going with something here to get in my mind. Okay, a researcher decided that instead of using a level of significance of 0.05, use 0.01, which of the following will be true. I don't know about the errors, but my first thought, well, I know the probability that the null hypothesis is true will decrease as false. It will increase.
Yes.
And so I think it's just that his experiment will be more scientifically valid.
That's kind of what I'm thinking.
Hmm.
Because I don't think the alpha has anything to do with how often the type 1 or type 2 errors occur, right?
Mm-hmm.
Yes, I think so, because there's less, if it's 0.01, there's less chance for screw up, you know what I'm saying?
Yeah. Wait, look at 22, 21. Do either of you guys know how to do that?
Just 5%, isn't it?
So type 1 is where you reject it, but it's actually true, right?
Right.
Yeah. How do you compute the probability of committing a type 1 error?
So wait, what did we put for 20?
I don't know. I said it's more scientifically valid, but then I saw
So did
21
I.
and I was like, whoa, I don't know how to say that.
I was
Yeah.
thinking the probability of a type 2 error will increase.
So what's your reasoning behind that? What's the
So
correlation then between the errors and the probabilities?
because like the type 1 is where you reject the null hypothesis and it was actually true, and type 2 is that you, I guess, failed to reject the null hypothesis but was actually false.
Uh-huh.
So I guess it's tied in that, if you lower it, then there's a possibility that it could be false, but you accept it still because it's lower.
Yeah, I see what you're saying.
Okay, let me see if I can repeat. Sorry. So the type 2 is that it is not true, but you accept it, right?
Yes.
It's
Okay, so then when you decrease the probability, like the alpha, to 0.1, you're going to accept a lot more,
Right.
but it may
Yeah.
not always be true. Okay, that makes sense. Okay, I'll go with that.
Yeah, I think you're right. Well,
At least it sounds super logical and smart. A lot more than the scientifically valid, so I'll go with it.
yeah, same. Well played.
So what I don't understand for number 21 is how you compute the probability of an error happening based off the alpha.
There was a question like this on the homework. I remember that. Like, I think all you do is the probability of committing like that type of an error is just like
Percentage.
the level of significance, because you have that little piece of where you could actually be wrong.
Wait, it's a level of significance, just a 0.05?
That they call it the level of significance. So if it's below that, then you usually conclude that it's the null is false. But if it was actually true, then that's a type 1 error.
Yeah. So it's a probability just the same. Then, like,
I think that actually represents a p-value, because you compare it with another p-value, right?
uh-huh. Yeah, that makes sense.
So
So then There would just be 0.05.
I think.
Wouldn't it just be 5%?
Yeah.
That's what the homework did. The homework just converted it to a percentage. Just said 1 out of 100, so therefore 1%.
Yeah. Yeah, I think I remember that.
Or would we do
So do we-
5 out of 100, therefore making it, no, it's still 5%.
Yeah. Do we do 5% or just 0.05?
Well,
The
usually
homework
when you
made
put
the
the percent, you usually put the percent symbol to the side.
Yeah.
So,
So just do 0.05, and it doesn't say to round to 3 decimal points, so I'm just going to copy exactly what's there, 0.05.
So
Alrighty.
what are we going to put then? 0.05?
Yeah, I'm just copying exactly how it is, so 0.05.
Okay. You ready for this?
Alright, we're ready. Here we go. Again. Just kidding, I have to submit it. Yay!
Yay! Good job, team.
Yeah. Nice job. They're getting a little tougher, guys.
Yeah.
yeah.
I really gotta pay attention on those assignments, those individual test assignments. Oh boy. Okay, cool. Well, so we just have this one homework assignment due on Saturday. It sounds like you guys have done it, so I need to get on that. And then our hangout again on Tuesday, right?
Yeah.
Okay. My hair's like really cute in the middle. Awesome. That's it for now, right?
Yep.
Do you guys have exciting plans for the long weekend?
Oh, no, right now. As of right now.
No. Not as of right now. Are your grandparents still there? Because that could be fun.
No, they're not here anymore.
Darn, I'm sure they would have made a good holiday.
Yeah.
Cool. What about you, Brand, up in Rexburg? Are there fun things going on?
Yeah, I'm just going home to my hometown. It's only about 2 hours away, so I
Where do you live?
live in Malta, Idaho.
Okay, that sounds like a little town in Idaho.
Yeah, it truly is. No one knows where it is, so get right on.
Cool. That's awesome, though. Idaho's great.
It is.
Cool. Well, I hope you guys have a ton of fun.
Yeah, you guys too.
And we will see you soon. Okay, bye.
Sounds good.
But
See ya.